The primary rule for adding and subtracting rational expressions is the same as the primary rule for adding and subtracting fractions. In order to do that, the two expressions have to have a common denominator. In example 9, we can see that's already taken care of. We have 3 over c minus 1 over c. Even though that's a variable, it's exactly the same variable, it's exactly the same expression. So we have a common denominator, which means we can merge these by performing that addition or subtraction step, whatever we have in the numerator, and writing the expression over that same common denominator, which in this case would just reduce to 2 over c. In example 10, we don't have a common denominator because our first rational expression has a denominator of c, second rational expression has a denominator of y. So what we need to find is the least common denominator, the LCD, of these two expressions, and then multiply, update the expression to rewrite it with that common denominator. In this case, and in a lot of cases, we can get that least common denominator, or at least a common denominator, by just multiplying together the denominators of each expression. And then we have to look at updating each expression. When we look at the first term, 3 over c, we have a denominator of c, but we have no y there, so we'll multiply by y over y. Doing this introduces the y in the denominator that we need to have that common denominator, and multiplying by y over y means we're just multiplying by 1. So we're not changing the value of the expression, just the way that it looks. And similarly, we'll multiply in the second term by c over c. Again, we're introducing the missing piece of that common denominator, but only multiplying by 1, so we're not changing the value of the expression. This will give us 3y over cy, the updated version of that first rational expression, minus 1 times c, or just c, over c times y, that updated second rational expression. Now we have common denominators, meaning we can merge the numerators using either the addition or subtraction step, whatever we have in our problem, and write that over that common denominator. We look for any like terms that might cancel or anything that might reduce, but in this case, we have this in simplest form. Similarly, in example 11, we need a least common denominator. We can get that by multiplying the two denominators together to get 12 times b times z. And we need to look at updating each term to get that common denominator. The first term has 4b in the denominator, so we need to multiply it by 3z over 3z. And the second term is missing 4b, so we'll multiply by 4b over 4b. Multiplying those together will give us, in the first term, 9z over 12zb, and I'm sorry, that's negative 9z, minus 16b over 12zb. Once we have that common denominator, now we can combine these two expressions by merging the numerators and writing it over that common denominator. Nothing in the numerator will combine, there are no like terms, so again, that's our final answer. In example 12, our least common denominator we'll get again by multiplying together the denominators of the two rational expressions that we have. We'll update by multiplying by what's missing in each denominator. So our first expression, will become b minus 1 over b minus 1, b minus 1 times b minus 1 over b minus 1 times b plus 1. And our second expression will become 2b plus 5 times b plus 1 all over b minus 1 times b plus 1. Our common denominator we can FOIL out to get b squared minus 1 because that middle term will end up canceling. So then we just need to look at FOILing out what we have in the numerators. B minus 1 times b minus 1 will give us b squared minus 2b plus 1. And then we're adding that second pair of binomials expanded. That will give us 2b squared plus 7b plus 1 all over that shared common denominator, which we know will expand out to be b squared minus 1. Then in the numerator we can look at combining any like terms, and this will give us 3b squared plus 5b plus 6 all over b squared minus 1. In this case, since we've taken the step to expand everything out, multiply everything out, we refer to this as expanded form versus some of those earlier examples we left in factored form. And again, it just depends on what a particular question is asking for or what next steps we might need to take as part of a larger problem to know which way to write our answer. In our last example, our least common denominator will be negative 3c plus 1 times c plus 2. Again, we'll update each expression by multiplying by whatever is missing from that common denominator. And we'll write our answer in expanded form again, so we can start by expanding these expressions out. The numerator of the first rational expression will be negative 4c squared minus 6c plus 4. And that expanded denominator will be negative 3c squared minus 5c plus 2. And we'll add to that the numerator of the second expression, which will expand to negative 15c squared plus 20c minus 5 over that same common denominator. And then we'll merge these together and combine any like terms to get a final answer of negative 19c squared plus 14c minus 1 all over that common denominator of minus 3c squared minus 5c plus 2. Again, written in expanded form since we've multiplied out all of those binomials.